Alright, well, here it is. 11.9, 11.10, and 11.11. That's the bulk of the next test. Really, 11.9, 11.10. I'm breaking that into 3 different parts. We're going to do one part today. So, we start off with this series. Let n equal 0, let n equal 1, n equal 2. And this looks like a polynomial. Not only that, do you see that you're actually multiplying by x every time? That makes it geometric. Wouldn't that be the very first term? In this case, it's, you know what, let me write it down because students make that mistake non-stop. The very first term is 1 in this case. How do you find the first term? Whatever that if this starts at 3, that would have been x cubed. Whatever the first term is, divided by 1 minus, and what's r? What are you multiplying with every time? You're multiplying with x every time. I don't know next step. So, provided absolute value of x is less than 1. What does this mean? This means I really gotta get used to seeing this and going from right to left, not the other way around. And automatically absolute value of x is less than 1. The radius and interval of convergence, that's easy. That's the radius right there, whatever that is. And the interval, you just solve that. Now, something to really point out. That has to be a 1. That has to be a 1. If that's the case, and that has to be a minus. That x is the only thing that you need. So that's what this is. They put it in there as number 1. Well, let's play with that. So if I glance at what that looked like, again, right here, I'm going to say this is 5 times 1 over 1 minus, and here it is. Everything's matching. The 1 is matching the 1 and the negative. And what's going to go in there? Well, basically, whatever that is, that is. So that is the series of 5 times n equals 0 to infinity. I'm just mimicking what this is saying. Of something to the n power. Find the power series and determine the interval of convergence. Okay, well, what's going to go in there? Well, isn't that a 4x squared? And automatically, so I don't lose track, whatever I substituted must be less than 1. That's always the case. Now, 2 things I need. 1, I need to really work this out and clean it up. That's going to be 5 times the series n equals 0 to infinity of 4 to the n x to the 2n. And if I really wanted to be picky, and I am picky, I want this to be to the n power if possible. And if I solve this, absolute value of x squared is less than 1/4. So absolute value of x is less than 1/2. Basically, x is between negative 1/2 and 1/2. What is that saying? That's telling you for what values of x with this series converge. A big deal. Not only am I finding a power series, I'm telling you the values of x for which this series converge. So I get to number 6. And, well, it doesn't match. Again, for now, it's good to really get used to this. I'm going to use that a lot. So for it to really match, I need that to be a 1. That's where I begin. I take a 4 and I factor a 3 out. And I say, look, I'm trying to mimic this. Or really this. If I factor a 3, 3 divided by 3 is a 1. Plus 2x divided by 3 is 2x over 3. And here I will say this is 4 over 3, but we have a problem. This is not a minus. So everything's matching, it seems. That's a 1, but that's not a minus. Well, that's easy. Can't I say that's really minus a negative 2x over 3? And now, when I look at this, I'll say this is, okay, I don't want the red color yet. that would be 4/3 the series n equals 0 to infinity of something to the n power. What to the n power? Again, if this is a 1, this is a 1, and that's a minus, there it is. That simple. 2x over 3. Before you go on, I would like you to go on the side, take absolute value of 2x over 3, set that to be less than 1, solve. There's my interval. I'm done with that. And then I'll go on and wrap this up. What is that? Well, that is 4 over 3, the series n equals 0 to infinity, 2 to the n, x to the n over 3 to the n, and that's going to be the series n equals 0 to infinity. Oh, I forgot. We said this was negative, wasn't it? So that's negative 1 to the n. That's going to be negative 1 to the n. Alright, guys. Isn't 4 2 squared? 2 squared times 2 to the n is 2 to the n plus 1. Plus 2. Same thing. And isn't this 3 to the 1 times 3 to the n? 3 to the 1 times 3 to the n. Isn't that 3 to the n plus 1? So, again, I want to be picky on those. If I could make that x to the n, I must make it x to the n. Here I couldn't. And there it is. That's actually what that equal as a series, and I'm telling you for which values of x would that even converge. Well, another problem is right there. Well, by now hopefully we memorized it's 1 over, so I'm going to take an x out, right? Over 1 in this case, and that's 1 over 1 minus a negative 2x squared. So I make sure that's a 1, that's a 1, and that's a negative. That works. The x I'll leave alone. This is the series n equals 0 to infinity, and all what I have to do is plug that in raised to the n, clean it up. There, not that bad. And I'll go on the side and say negative 2x squared should be less than 1. So absolute value of x squared should be less than 1/2. X is less than 1 over radical 2. So my interval, x is between negative 1 over radical 2 and 1 over radical 2. That's my interval. And how does that play? This is x times the series n equals 0 to infinity. Negative 1 to the n to show it's alternating. 2 to the n, x to the 2n. And if I multiply those two, if I multiply x to the 2n and x to the 1, wouldn't that become the series n equals 0 to infinity, negative 1 to the n, 2 to the n, x? Isn't that 2n plus 1? And there's my solution. Again, if this is shifted up by 1 or down by 1, I could fix it. But if it's 2n, indicate that's even. You can't fix that. And 2n plus 1 or 2n minus 1, those are the odds. You can't fix that either. You could only fix it if it's shifted up or down by certain values. You know, n equal 2, n equal stuff like that. And n plus 2 and stuff like that. If I look at problem number 12, well, it's not matching really. It doesn't look like that at all. I can't fix an x squared, but I could say this is x plus 2 into x plus 1. And I could say that's a over x plus 2 plus b over x plus 1. And if I work this out, if I let x equal negative 1, I'll get 1 to equal, so that's 1. And if I let x equal negative 2, negative 4 over negative 1, that's a 1 as well. So basically, we're saying f of x, they're using that notation, is 1 over, to make that a 1, I factor a 2 out, right? And that would make it 1 over 2 divided by 2 is 1. X divided by 2 is x over 2, but I want it to be negative, so there it is. And the second piece is simply 1 minus a negative x. So this is 1/2 the series n equals 0 to infinity of since all of these match again, all what I have to do is worry about that piece and say that is negative x over 2 to the n plus, this is going to be the series n equal 0 to infinity of negative x to the n. So that is 1/2 the series n equals 0 to infinity, negative 1 to the n, x to the n over 2 to the n. This is the series n equals 0 to infinity, negative 1 to the n, x to the n. And if I play with that a bit, that is the series n equals 0 to infinity, negative 1 to the n, x to the n over 2 to the n times 2 to the 1 is 2 to the n plus 1. And here it's the series n equals 0 to infinity, negative 1 to the n, x to the n. I could combine those and say that's the series n equals 0 to infinity, because they both start at the same. And all what I care about is getting x to the n out of that. Negative 1 to the n is common in both. And on the first one, 1 over 2n plus 1. And if I factor that, that's just a 1. So it is very important if you can write your series as the series a sub n x to the n. That's very important to separate between this. This part is what we did on 11.2 through 11.7. Oh, I almost forgot. What would be the radius of convergence or interval convergence? On this piece right here, this indicates absolute value of x over 2 is less than 1, right? That means absolute value of x is less than 2. This indicates that you are between 2 and negative 2. This indicates that absolute value of x is less than 1, so x is between negative 1 and 1. And if you're looking for domain for multiple cases, don't you take the overlap? So here you would say negative 1 to 1, or x is between 1 and negative 1. You want an interval that satisfies both cases at the same time. And there it is. Okay, now we want to talk about the calculus of series. That is, theorem 2. Given a power series, that is, plug n equals 0, n equals 1, n equals 2, all the way up, that's the series. Now, I suggest, this is only me, that you list few terms every time you want to do this. It's highly recommended. So, because there's a catch for you when you take a derivative. They say it's differentiable and continuous, which means you could take a derivative and you can integrate. However, when you take a derivative, if you're looking at the expanded form of the series, you don't need all of it, just few terms. Not this. This. If I take a derivative, wouldn't that right there be 0? And wouldn't that be C1? Right? And that would be bring the power down, subtract 1 from the power. And that's what they did right there. But the deal is, do you need to see that I lost a term by taking a derivative? If I could see that, and I could see that only from the expanded form, do you see how they write it? Instead of you taking a derivative of each of those, they say, you see that power right there? Apply what you know. Bring the power down, subtract 1 from the power, just to the x part. But the catch, if you lose a term, you need to really highlight that. Sometimes you take another derivative. You have to look at what's left. If the power is x to the n, you can lose a derivative every time. But if the power is x to the 2n, then you got to be more cautious with that. And if you integrate, integration is straightforward. If you want to integrate, well, the integral of this, add 1 to the power, divide by that, don't forget the c. And integration, you really don't touch the index. And the radii of convergence for both, well, that's identical to what we've been doing. And in the next video, I'm going to start number 14.